Here's an example of the sorts of questions you might have to deal with uniform electric fields. Here we've got a couple of parallel plates with a field drawn between them. The field lines are going from top to bottom, so I'm going to go ahead and put a plus sign up here as it must be the positive plate. First question. If the electric field strength is 3.0 times 10 to the 4 newtons per coulomb, what's the potential difference? This would be worth 3 marks in a test. I'm going to start off with the formula E equals V over D and rearrange it to V equals E times D. Always rearrange first, it helps avoid mistakes later on by keeping it simple on your piece of paper. Oh, and do use a piece of paper or something to write things down, don't just put the numbers in your calculator. So, V equals 3 times 10 to the 4 times 1.2 times 10 to the minus 2, don't forget to use meters, giving us 360 volts. Next, for another 3 marks, what would be the acceleration of an electron if placed in here, assuming it's in a vacuum? Well, F equals ma, so A equals F divided by m. And from E equals F over Q, we have F equals EQ. So A equals EQ over m, which is 3 times 10 to the 4 times 1.6 times 10 to the minus 19 divided by 9.1 times 10 to the minus 31. Giving us A equals 5.3 times 10 to the 15 meters per second squared. Put the units on every time, remember that. Okay, that's 6 marks. Now on this last one though, what about gravity, you might be wondering? Well, to check that we need to take the force due to gravity into consideration. So let's call that W for weight. So A equals F over m becomes A equals F minus W over m. That's equal to EQ minus mg over m. So we've got 3 times 10 to the 4 times 1.6 times 10 to the minus 19 minus 9.1 times 10 to the minus 31 times 9.81 divided by 9.1 times 10 to the minus 31. Right, okay, got that. That tells me the calculator 5.274725.275 times 10 to the 15 meters per second squared, compared to my previous answer, which was 5.274725.275 times 10 to the 15 meters per second squared. No change in the values. Okay, maybe I've done something wrong. Okay, but they look like they're the same. If I double check that on a spreadsheet, it gives me some more significant figures. I get 5.274725.274.725.270 and 5.274725.274.725.260. So the 15th significant figure changed. I think from that we can safely assume that the force due to gravity is negligible.